Let's look now at what happens when we have a situation like this. You may have seen this before in algebra, a 2 outside of a bracket, which means, well, what does it mean? What symbol do we not write in algebra very often that would go here? That's right, it means 2 times x plus 4, which means 2 lots of this bracket. So I've got one lot of that bracket and I've got another lot of that bracket. So how much have I got in total? Well, if you use your rules for simplifying, you'd have 2x plus 8. Can you see a simpler way of getting from here to this answer? Let's try another just to check. Five lots of x plus 3. One lot, and another lot, and another, and 2 more. So in total, we've got 5 lots of x plus 3. X gives me 5 lots of x. 3 gives me 5 lots of 3. Now, rather than writing this out, I'm beginning to see that I get 5 lots of the first term in the bracket and 5 lots of the second term. So 5 lots of the first term and then 5 lots of the second term. Okay, let's see if we can use this rule then. Three lots of the first term and 3 lots of the second term. So 3 lots of minus 5, which is minus 15. Because 3 times 5 is 15, so 3 times minus 5 is minus 15. Okay. I want to do 3 times the first one and 3 times the second one here. But actually it's 3 lots of everything. So it's 3 lots of this, 3 lots of this, and then 3 lots of that. Okay. If at any point you want to write these down, pause the video and make a note. Minus 2 multiplied by a. Minus 2 multiplied by 4. the negative outside changed both terms into negative. Okay, let's try one more with the negative and see what happens. Minus 5 times b minus 5 times minus 10. I'm writing these out for you to remind you of the method you can use to get your answer. Change 1, change the answer. So it goes back to plus 50. So we've covered the basic idea of multiplying each thing inside the bracket by the number outside. We've dealt with what happens if there's a negative in the bracket. What happens if there's more than two things in the bracket? What happens if there's a negative at the front of the bracket? Let's look at some more scenarios. Now the fact there's a decimal in there makes no difference. Three lots of 0.2 is 0.6. Does it make any difference if we have higher powers inside our bracket? No. 5 times a squared is 5a squared, because actually this means 5 times a squared. 5 times 2a, 5 times 2 is 10a. By now you're starting to get confident, so I'm going to write up all the ones I've got left to show you, and you can try some of them before I go through. Each one is designed to show you a slightly different scenario. Some may be obvious, some may not. In some cases you may be able to just do them, or certainly want to try them. It's really important when you're listening in mathematics to a teacher that you try for yourself and think in your head. See if you already have the ability to connect the ideas. Now don't be worried by the number of examples, because they're all very subtle checks on rules that you already know. What we're doing is we're applying them in different situations, like we've done so far when we considered negative numbers and when we considered decimals, an example at the top of this page. If you feel confident on this topic, you can try all the questions now and skip the video to the end. I'm going to begin shortly, so if you wish to try them, pause now. Here we go then. 2x times x is 2x squared, because x times x gives me x squared. And remember, this term is that multiplied by that. 2x times 4 is 8x. 5x times x squared, well, x times x squared is x cubed, so it's 5x cubed. 5x times 2x. 5 times 2 is 10. X times x is x squared. And then 5x times 3 is 15x. (10a) times 3 is 30a. 10a times minus 10a squared is minus 100a cubed. What we've been looking at here in these last three is what happens when we have a letter outside the bracket as well. And we've checked what happens when there are three terms inside, and we've checked that we can have higher powers. Speaking of higher powers, that's 2x to the power of 6. Minus 2x cubed. So it's 3. A times a is a squared. There's a b here, but no more b's, so it's times by b. It's very important you don't put the squared on the end because there's only one b, but there are two a's multiplied. 3 times 3 is 9. ab times c, well, I can't actually work that out, so it's just left as abc. Okay, starting to get harder now with the powers. 2 times 3 is 6. A squared times a is a cubed. B times b squared is b cubed. I go numbers first, then go down through the alphabet. Now, 2 times minus 3 is minus 6. A squared times a is a cubed. B times b is b squared. By now you're feeling quite confident, this is quite repetitious, and that's good. It's using all the rules you're already comfortable with and just applying them to a different situation where you have to use indices, you have to know your times tables, and you may have to know your decimals and your fractions. Speaking of which, half of 2a is just a. Half of 4 is 2. In trying to find 2/3 of something, I'm going to have to make sure in my head I find 1/3. So 1/3 of 3a is a, so 2/3 is 2a. 1/3 of 6 is 2, so 2/3 would be 4. Make sure you get the minus there. One quarter of x, well, that can't be done. Or you can write it as x over 4. And those two mean the same thing, because finding a quarter of something, you divide by 4. A quarter of 3 is 3/4, because 1/4 times 3 is the same as 1/4 times 3 over 1, which is 3 over 4. A long video there with lots covered, and hopefully you feel confident now that you can expand brackets when there is just one bracket. We'll look at factorising and then we'll look at more than one bracket in the next parts.